Hello, in this video we're going to be looking at how the first and second derivative tests apply to implicit relations. In this example, we've got this curve C. We know its derivative. We want to determine if there's a maximum or minimum at that point. So what I'm going to do first is I just want to know what is going on with the value of that derivative. So dy over dx at this point 0, 2 is going to be 4, my x value is 0, and then we end up with a value of 0. So by our first derivative test, we know that there's got to be a maximum or a minimum value at that point. In order to determine if it is a maximum or a minimum, I'm going to take a look at the second derivative and see what's going on there. So d squared y over dx squared is going to be the derivative of our top, which is 4, multiplied by the bottom, which is 9y, minus the derivative of the bottom, which will be 9 dy over dx, multiplied by our top. So that's 4x. And then this is all going to be over the bottom squared. So that's 9y squared. Okay, so now we want to see what the value of our second derivative is at that point. I'm going to cheat a little bit. Like I could plug in this dy dx, but we're checking what's going on with dy dx at the point 0. So why don't we just use this 0 over there? So we know that that whole second term in the numerator has got to be 0. With that 4, 9y, we got to plug in our y value, which is negative 2. So that's 4 times 9 times negative 2. Minus 0 over. In the denominator, we're going to put that negative 2 in, so that'll be 9 times negative 2. I'm kind of going a little crazy with parentheses there, but whatever. Okay, so d squared y over dx squared equals, the numerator is going to be, it's going to be pretty big, but it'll be negative 72 over our denominator squared, which will be, here I got 324. The important thing is we can see that this thing is less than 0. At this point, we're concave down, it should be a maximum. So now we just want to write out our statement. So C has a maximum at negative 2, 0, since at that point our derivative equals 0 and d squared y over dx squared is negative. You could add by the second derivative test, it has to be a maximum, but it's nice to have. I don't think it's a need to have for this problem. In this example, I'm given a curve and I've got some statements that I want to check out. So a lot of them have to do with the tangent line. So I want to figure out what is going on with our derivative. So I'm going to find dy over dx. This one's not going to be much work, so it'll be okay. So I get 3x squared plus 2y dy over dx minus 12 plus 16 dy over dx equals 0. So then we can find our derivative dy over dx by just kind of saying, okay, a couple of our things are going to go to the other side, this 3x squared and that minus 12. So it'll be 12 minus 3x squared. And then we'll divide by these other pieces, this 2y and that 16 after we factor out the dy dx. So that'll be divided by 2y plus 16. The first one I want to go after is this bottom one. I want to see what's going on with this 1, 1, because that's pretty easy to plug in. So at that point, dy over dx at the point negative 1, 1 equals, let's see, that's 12 minus, 3, because that's going to be a negative 1 squared, over 2 plus 16. So that is 9 over 18, which is a half. Okay, cool. So this first one is true. We know that that one is correct. Let's check the other one. The other one is when the x values equal negative 2, we have horizontal tangent lines. So let's see what's going on there. So then dy over dx, when x equals 2, negative 2, is going to equal, let's see, that is 12 minus 3, and then a negative 2 squared. And then the 2y plus 16 is just going to stay the same thing. So in the numerator, we get 12 minus 12. So that's 0 over that 2y plus 16. And oh, that is 0. So a horizontal tangent line would have a slope of 0. And so, yeah, we have a horizontal tangent line whenever this x equals negative 2. So that one also seems to be true. The last one is if we plug in a negative 8, and we can kind of hand wave that one at this point because we can kind of just say, hey, if we put a negative 8 right there, we would get 2 times negative 8, that's negative 16, plus that 16, we would end up with a 0 in our denominator. And if we have a 0 in our denominator, then we would have vertical tangent lines because we're not able to have a 0 in our denominator for our slope. So um, that is true. So it turns out all three of these statements were true for this problem. This next example is again looking at horizontal and vertical tangent lines. So we want to take a look at what is going on with our tangent lines, and that's derivative. So finding the derivative of this, we get, nope, not an x, just a 1. So that'll be y squared plus the derivative of y squared, which is 2y dy over dx, times our first thing, which is x, doing a little product rule there. Derivative of 2 is going to be 0, and then we have to define the derivative of that xy. So that'll be y plus dy over dx times x. Now I've got to do a little bit of solving here. So I'm going to subtract this dy dx x, and then I'm also going to subtract this y squared so we can get all the dy's together. Hey, I don't want to move. I just want to slide down a little bit. Okay, so we get 2yx minus x, factoring out our dy over dx, equals y minus y squared. And then we divide both sides by that. So we get dy over dx equals y minus y squared over 2y x minus x. So now we want to figure out if we've got horizontal tangent lines, that means our slope is 0. So our slope is going to be 0 if this numerator is 0. Our vertical tangent lines are going to be when our slope is undefined. So really, this question is asking about when is this numerator equaling 0, or when is this denominator equaling 0. So if we check the numerator, we get y, and then y, let's see, 1 minus y, excuse me. So that would be the y value of 0 and the y value of 1. Those are two places that we can have horizontal tangent lines. If we check this horizontal thing, I'm sorry, the vertical thing, when is that denominator going to equal 0? So that would factor out to x, 2y minus 1 equals 0. So if x equals 0, we can potentially have a vertical tangent line. And when y equals 1/2, we can potentially have a vertical tangent line. So potentially we've got 4 places. But we got to make sure that these values actually work up in our merjigger, this thing. So I've pulled that down there just to make sure we don't get anything weird happening. And unfortunately, we do. If we try this first value of y equals 0, we get 0 equals 2 plus 0. But that doesn't make any sense. 0 does not equal 2. So we don't have anything going on with horizontal tangent lines. It never goes to the point of y equaling 0. So this one doesn't work. Let's try another one. Try this y equals 1. So that gives us x equals 2 plus x. And then we try to solve that. Minus x, minus x. We got another one of those 0 equaling 2. And that's not true. So that one also doesn't work. So we're not looking very good for finding horizontal tangent lines. In fact, actually, we have none. Then we got to try some more. Let's try this one. Let's see if this one gets us anything good. Nope. This is going to do 0 equals 2 plus 0. So again, that's not quite working out for us. So yeah, no, that one's not working. Our final one is that y equals 1/2. Hopefully this one will work. So this gets us an x and a 1/2 squared equals 2 plus x times 1/2. So then let's see. So that's a quarter x equals 2 plus a half x. You subtract, I'm going to multiply everybody by 4. So that's x equals 8 plus 2x. This is looking really good. So we get negative x equals 8 and x equals negative 8. Hey, cool. So we did get a point. So we do get a vertical tangent line at y equals 1/2, but we're not going to get any of those other ones. So we only get a single vertical or horizontal tangent line. That is the end of this video on implicit relations and the first and second derivative tests. Hopefully you see that the ideas of the first and second derivative test still apply to implicit relations, that just because it's an implicit function doesn't mean that we need to do anything special with the first nor the second derivative tests. Thank you for watching. I hope you took some good notes, and see you next time.